Alright, so let's talk about a simple reaction of epoxides, and this is epoxy opening with a nucleophilic addition. So the nucleophile, basically what we're adding here is we're adding an H, and we're adding some nucleophile with a negative charge. So this could be something like HCl addition, or this could be something like an ethoxide addition to give us an ether and an alcohol. Which way does it go? So I've intentionally written an asymmetric epoxide here. On the one side we've got two methyl groups, on the other side we've got a methyl group. And there's a reason for this. We can go through all types of iterations of this reaction, but the big question you have to ask yourself is, which carbon does the nucleophile attack? Does it attack the more substituted or the less substituted carbon? And that's going to depend simply on if you're working under acidic or basic conditions. So what happens underneath acidic conditions is that we're going to go through a carbocation intermediate. And as you may have guessed, this carbocation is going to have to appear on the more substituted carbon. Now, where this comes from is that if we're working at acidic conditions, we have lots of H+. Well, the H+ is going to add to the oxygen to give us the intermediate compound. Subsequently, our nucleophile is going to attack, and we're going to get the nucleophile added to the more substituted carbon. Now, because we're going through a carbocation intermediate, we're going to get a racemic mixture of both the R and S configurations. It's kind of inconsequential to this discussion, but just keep that in mind. Once you go through carbocation, you lose all selectivity. How about this one? Well, if we're under basic conditions, we don't form the carbocation, and what's going to direct the reaction here is sterics. So our more substituted carbon in this case is harder to access because these methyl groups are in the way, whereas this ethyl group kind of leaves it open for attack. We've got that hydrogen kind of sitting out here. So when it comes to the basic conditions, our nucleophile attacks first. Now, this has a lot of strong implications. One, we don't go through a carbocation intermediate, and we definitely get attack anti to the oxygen. So this is going to set the stereospecificity of this reaction. We're not going to get a racemic mixture. We're going to get an enantiomerically pure mixture wherever the nucleophile attack is concerned. The second is that we're going to end up with the alkoxide when we finish. So when we really truly finish the reaction, we're going to have to finish with an acid workup, add H+ to give us back to the alcohol. So any addition to an epoxide ring is going to go through this process. We're going to have a nucleophile, and we're going to subsequently add H+. If the H+ is present in the reaction itself, meaning we're underneath acidic conditions, we're going to end up with the epoxide opening up and putting the alcohol on the less substituted carbon, with our nucleophile being attached to the more substituted carbon. In the case of basic conditions, let me back up. And in the case of acidic conditions, you're also going to end up with racemic mixtures where that nucleophile attaches. When it comes to addition under basic conditions, we end up with a racemically pure compound with the nucleophile attacking anti to where the epoxide is attaching. On top of that, we have to follow this up with an acid workup in order to recover the alcohol from the alkoxide. So this is it. If you add something like HCl, HCl is acidic conditions. The Cl is going to attach to this side, and you're going to get the OH, and it's going to be both the R and the S. If you add something like sodium hydroxide, for whatever reason you want to create the diol, you'll add it over here to less substituted carbon, and then you'll follow it up with an acid workup.